In this example, we have a bunch of radical expressions that we want to add or subtract. And the key here is that we're looking for like terms. So for instance, in part A, we have rad 27 minus rad 75. Let's start by reviewing a simple example. Something like this: 3x plus 5y plus 2x minus y. Okay, right, so this, we combine like terms, so the x's go together and the y's go together. That gives us 3x plus 2x, 5x, 5y minus y, plus 4y. Okay, that's the key of what we're looking to do here, but with these much more complicated examples. 27, we're looking for a perfect square inside of the 27, because when there's nothing here, right, this is really a square root, and this is a square root. So we're looking for perfect squares. Well, 27 is 9 times 3, and here's our perfect square. 75, we're looking for perfect squares tucked into the factors of 75. How about 25 and 3? Okay, so we rewrite this as rad 9 times 3 minus rad 25 times 3. Okay, well the 9 breaks out as a 3, and the 25 breaks out as a 5. Right, so that gives us 3 rad 3 minus 5 rad 3. And now we have like terms, right? Rad 3 and rad 3, these are the like terms that we were looking for. Like terms. Okay, so 3 minus 5 is negative 2, giving us a final answer of negative 2 rad 3. B is a little bit more challenging, right? A little bit more going on, but not the end of the world here. We have 45. Again, we're looking for perfect squares. 9 and 5. There's our perfect square, 9. Same thing with x cubed, right? We can break that down into an x squared and then an x. Okay, so let's rewrite this as 3 times rad 9x squared times 5x. I'm just rewriting it a little bit. And then we'll leave the second term alone, plus x rad 5x. Well, square root of 9 is 3, so out comes a 3. Square root of x squared is x, so out comes an x. But 3 times 3 out here is 9. So that gives us 9x rad, what's left behind? This 5x. So 5x plus x rad 5x. Now, for these to be like terms, the entire configuration of variables and radicals has to match, and here they do. This is our, we can think of this as our kind of set of variables, so to speak. We have an x rad 5x, x rad 5x. Really, this is 1 x rad 5x. And then 9 plus 1 is 10, giving us a final answer of 10x rad 5x. 10x rad 5x. There we are. Again, we're looking for these like terms so that we can combine these and ideally get these down to a single expression in the end. Not all of them will, but a lot of them will. Let's try C. 4 rad 32 minus rad 18 plus 2 rad 128. Okay, hopefully we can get these to have the same configurations of radicals so that we can combine like terms. That's what we're always looking to do here. Let's see, 32, we're looking for perfect squares inside the factors of 32. What do we have? Well, how about 16 and 2? There's our perfect square. Right, 18, same idea. 9 and 2, there's our perfect square. Well, let's keep the same theme. And you can kind of, this gives us a little bit of a hint. It's kind of a cheat code here, right? We are looking for these 2's. So 128, there's a lot of ways we can break that down. But we know that we would really like to have a 2 left over, right? Because that's what we're going to use to combine with the other ones. And indeed, 128 divided by 2 is 64. Okay, and there's our perfect square. Rewriting this a little then gives us 4 rad 16 times 2 minus rad 9 times 2 plus 2 rad 64 times 2. Right, well 16 is 4 squared, so out comes a 4. Combining it with the 4 that's already out there gives 16 rad 2 minus, all right, 9 comes out as a 3, 3 rad 2 plus 64 comes out as an 8. 2 times 8 is 16. 16 rad 2. And now we have the like terms that we wanted. Rad 2, rad 2, rad 2. All right, so then we just do 16 minus 3 plus 16. That comes to 29. 29 rad 2. Final answer there. Sometimes it's surprising how different these can look at the beginning and how much they simplify at the end. So don't give up when they look completely different right off the bat. Let's try D. 3 rad 7 minus cubed root of x plus 4 rad 7 minus 3 cubed root of x. Okay, so the point of D is just to show that we don't always have all the terms being like terms. Right, here we have 3 rad 7 and that goes with 4 rad 7, but there's no way to combine those two with cubed root of x and 3 cubed root of x. So in this example we have two different kinds of terms. So let's do it. 3 rad 7 plus 4 rad 7 is 7 rad 7, and then we have minus 1 cubed root of x minus 3 cubed root of x is minus 4 cubed root of x. Here we go. No further simplification on that one.